Nice geometry problem here. We've got two squares and an equilateral triangle, and we've been asked to prove that AXZ is an equilateral triangle. So let's highlight that, AXZ. So the thing that's jumping out is probably to try and show that the angles are all 60 degrees. Now, there's two little points that are really useful, and that is because the equilateral triangle shares a side with this left-hand square and with the right-hand square, then all the side lengths are the same. Okay, if I was doing this in a real thing, I'd probably just say since the equilateral triangle shares sides with both. And another really important thing, or not important thing, but a useful thing, is that AZ is clearly equal to AX. And that results from the fact that the squares are the same size, since both are diagonals of the same sized squares. So if we can, so I've got an isosceles triangle, therefore triangle, and we're halfway there. Because if I can work out any one of the angles, I can work out the other two. So I'm going to concentrate down here. This is going to be 45 degrees because it's splitting 90 degrees into two. And then this angle here must be 15 because the angles in an equilateral triangle add up to 60. Okay, this would be written down in the real thing. I'm just explaining it verbally here. And because this is 90 degrees and this angle is 30. But this is also 45, and then this is 90 degrees, so this one is also 15. And actually, pretty much gone and done it. Angle ZAX must equal 60 degrees, and therefore angle AZX and angle AXZ are also 60 degrees because it's 180 minus 60 divided by 2. And that's the isosceles bit. So it can be that quick actually, because they're all 60 degrees, then AXZ is equilateral. Now, when I did this question, I didn't actually spot the diagonal bit, and so I went down a slightly different path. It's a longer path, but I just wanted to talk about it. I can put 90 degrees here and 90 degrees here, and then I've got this four-sided shape, quite a kite. It must be a kite because the sides are the same length and these two opposite angles are the same here. So I can add up the 90s, 180, and then the 30, 210, and do 360 minus 210, which is going to be 150. This is going to be 150, which means this is 150 because they are vertically opposite. And then because I'm going to give this point a name now. BD is equal to BY since we have a kite. We could, if you wanted to prove that, you could draw a line down here and show that they are congruent, but I'm not going to do that here. But the result is therefore that ZD is going to equal XD. Okay, because these two are the same, and because BX is equal to ZY, then these two are the same. And I've got an isosceles triangle ZXD. And that means that this is going to be 15 and this is going to be 15. And I can combine that with the 45 here because of the diagonal and 45 here because of the diagonal. It's just another way of showing that I get 60 degrees. Okay, I don't need to do all this. Like I said, right from the start, that was fine. But if you don't spot it, then this is an alternative path. All right, well done.